Hey guys, today we're going to talk about the speed of sound. This is a real quick set of notes and hopefully we'll be through it in no time. So the speed of sound does depend upon the medium. If it's a solid, it actually travels fastest because the molecules in that solid are so close together. They don't have to move very far to transfer their energy to the next molecule. Liquids are a little bit slower because the molecules are a little bit farther apart, so they have to travel a little bit further to transfer that energy. And gases actually take the longest amount of time because the molecules in gases are so far apart that they have to travel a decent amount just to transfer the energy to the next molecule. The speed of sound is determined by the equation V equals F times lambda, or the frequency times the wavelength. We've used that in the universal wave equation, but now we're going to look at it in terms of the temperature, because it does depend upon temperature. Remember, cold things move just like solids do, like awkward dudes on the dance floor. Warm or room temperature things move like liquids. They're not super fast, but they have free flowing motion. And hot things move like a mosh pit. So they bounce around, they transfer the energy really quickly. So the speed of sound does directly relate to the temperature of those molecules simply because cold things move at a slower rate. In the wintertime, you don't necessarily want to get up and move around the house right away. You want to stay in your warm covers for as long as possible. The warmer you are, the faster the molecules move. So we have this equation on the bottom of the screen. The velocity of sound is equal to 331 meters per second plus 0.6 times the temperature in degrees C. So note, this is the same as zero point 0.6 times temperature in degrees Celsius. Here, all you are plugging in is a number value. A lot of times people get confused by the units, the fact that it says degrees C or T degrees C. They think that they're supposed to be multiplying something. Well, you're supposed to multiply 0.6 by a value, but in that parentheses, there is no additional math. So let's do a practice problem. Determine the speed of sound on a cold winter day when the temperature is 3 degrees Celsius. So we have our equation, V of sound equals 331 meters per second plus 0.6 times degrees C. So V of sound is 331 meters per second plus 1.8. So the velocity of this sound traveling through the air at that temperature is 332.8 meters per second. So the higher this degree C is, the bigger this number is, the faster it travels. So this is all we're doing today. This is going to be the easiest practice set that you're going to be looking at. So I'll see you in class so we can take a look at this and practice a little bit more.